So guys, as I mentioned before, it will be our final session, but I hope we will meet in some other, I don't know, sessions or any other events, okay? Yeah, so it will be fourth week and slurry cement properties and laboratory testing. I will talk about this. We have more 1 hour time, okay. So slurry cement properties. I just directly starting. I have already explained that what is slurry and what is set cement. I have explained what is the difference, right? First one is a kind of liquid because it is slurry. You mix water, you mix additives, dry and chemical additives, and you are adding cement inside. Okay, and this is going to be slurry. And also we have a cement, which is slurry is getting solidified and it turns up as a cement, set cement. We call it cement or set cement. Properties of slurry and the properties of set cement, which are separately defined in the lab, on the rig side, etc. Okay, we will go through one by one, and you can take a snapshot, or we will share this presentation with you, and you will find out that this information, wherever you go for cementing job or you go in cementing laboratory testing, you will see these parameters, and you need to be familiar with that if you are interested in cementing. Density for slurry, easiest version, because we all know what is density, right? And we know how we measure density. But for cement slurry, it is a little bit different. We have, as it is not a solid, it is liquid, and we are using a pressurized mud balance. I will show you how it is used, and I will maybe I will tell you a short story about this one, my first experience. And slurry thickening time, very important parameter for slurry design, like critical one, fluid loss, free fluid. And also I will mention about the compressive strengths and the sonic strengths that we need to measure in the job. First one, we can cover the slurry preparation first, because in order to measure any property, first we need to have a slurry. And how we mix slurry in the lab, because on the I have mixing, and there is a mixing on fly. But in laboratory, we have a special tool, special machine. We are mixing slurry. Okay, you can see it in the right hand side, this chandler. So it says a mixing bowl, and we are adding water, measuring the water, how much it is required, because in the lab we are always preparing it in the 600 milliliter or 600 milliliter or 800 milliliter. There are two options, so in each lab you can see different sizes, and the usual ones is 600 and 800 mLs. Milliliters. So this one, I guess it is 600 milliliter, and you get probably each company having special software, having special system, which is calculating lab units. You are adding concentrations, and it gives you the exact grams, exact milliliters. That's milliliters of the chemicals, additives you need to add this slurry recipe. So you get this lab sheet, and then you take all these chemicals from this list, you measure, and then you are measuring first water, then you add your liquid chemicals, and you are blending your dry chemicals and cement in other place, and then you add your water mixed fluid, we call it right now, right? Last time I mentioned about mixed fluid that we are preparing on the rig. So you add your mixed fluid, and then you are adding your blend, which is cement and other dry additives. You are adding, and this machine has two different speeds, 4,000 RPM and 12,000 RPM. So you add first 4,000 RPM is working, you are adding slowly your blend, your cement, it is getting mixed, okay, and then you are getting your slurry. But usually after we mix it, API says that you need to have a 30 second of high-speed mixing. That's just to simulate real rig operation in the lab. I have mentioned here that the how the cement testing starts. So actually cement testing begins in the manufacturer's lab, okay? They manufacture cement, they have special ovens, they cook the cement. That's how they call it. They cook cement, and after cooking cement, they measure its quality. If it is ready to go for sale to service companies or for any company who is cementing operations provider. And yes, this cement quality is measured. This is the first lab stage, and then this cement comes to the let's say to the company I'm working, okay? From manufacturer from US in any plant, cement plant, it was lab testing started as a quality measurement, which is covered in API 10A and the ISO standard. So it comes to the Baku, to the company, to the lab I'm working, and we are starting testing slurry design stage, okay? We just do quick quality check and then slurry design stage. And slurry design stage, we are measuring these slurry properties, all of them. So do we test all of this every time? No, because some of them are very specific for jobs, like fluid loss. If I'm not adding any fluid loss control additive, I don't need to measure fluid loss because I didn't do anything to control it, and it can give 200 ml or milliliter or 500 milliliter. I cannot because I didn't control it. I don't need result. If I don't need any control, I will not test it, right? So we do this slurry design stage at the pumping service company laboratories. That's what we have in Baku for each service provider. For Schlumberger I'm working for, and for Halliburton or for Baker, all have a cementing labs. So there are two manuals we need to refer. Each company has their specific, more tight rules, okay? But for general manuals, all companies should follow the recommendations from APR and ISO, because these are standards that we cannot ignore, okay? First one, API 10A, and this is for cement quality, cement and cement materials. And API 10B is for slurries. It is recommending practice for testing cement, like after you mix, okay? You can access them from internet, I guess. I have got it from company, but I guess you can find it online. And you can look through if you are interested. You will see all the procedures, all the recommendations they have provided for cement analysis. And first one, we mix here in the right-hand side. I have prepared some videos from my phone, like I have taken myself, but I couldn't upload them here. Maybe other times I can share it. Pressurized mud balance density measurement. After you mix, from this one, you switch to this. First, you need to check that you have mixed right density slurry, and this is pressurized mud balance. How it works, you add your cement slurry in, okay, you close, and then this is kind of portion, and you apply some pressure in pressurized mud balance, okay, and when after it is closed, when you complete your pressure, then you take it. It is, you see here there is a balance, and you are placing it, placing this tool, and then like usual balance, right? You try to balance it with this weight, small weight, and it will show you exact density. This tools, pressurized mud balances, usually has two lines, one for PPG and another is for pump purposes. We are slurry density, and the second one is for rheology. And probably if you have studied in petroleum engineering, you have heard about viscosity and rheology. Like I'm 100% sure that you should hear. So you need to measure rheology. And when you pump cement slurry, we are pumping mud, spacer, slurry, and this one should have a hierarchy. Look, for density, we have a hierarchy. Mud density should always be smaller than, like, should always be lower than spacer, and spacer should always mud density lower than spacer, spacer lower than slurry. What it gives to us? It gives us hierarchy and better mud removal. Look, mud and spacer comes and push mud away from well, and then slurry comes and this is pushing spacer away. This is 99% we follow this rule. You can find a job that, okay, the same densities has been used or mud density is higher than others. This is very, very specific cases, and you have unusual cases in the well. That's why this hierarchy is not used. So very critical cases. I have seen 1-2 cases that this is not a normal procedure. Okay, for 99% it should be mud density, the same for rheology. Okay, mud density rheology is lower than spacer mud rheology, and spacer mud rheology is lower than weight and rheology density. You can call density or weight, okay? Don't confuse them. So mud lower than spacer, spacer lower than slurry. Densities and rheologies. It is applicable for both parameters. And I have mentioned here some readings, okay? We call this number readings from real measurement that I have measured. So this is a viscometer. For this viscometer, you can see different types because currently there are some very upgraded version that it is with sensor, and you don't need to rotate this part just to get the different RPMs. You have a like kind of phone. You have a sensors, and you just click on the 1, 2, 3, 4, 5. There are numbers. This is very upgraded one, but I have told that these ones are not very accurate. That's why we are using this old version one. Yeah, how you use it? You add your slurry to the cup you have here, okay? To the cup, and then you are placing that cup in the viscometer, which has a balls inside, and this one is getting rotated, and you are getting friction there, and it is measuring for each RPM. You just switch from 3 RPM to 6, 30, 60, 100, 200, and 300. These RPMs, and you get readings. You are reading degrees, okay? And for these degrees, you write down, you go first up, you are starting from 3, 6, you get the readings, you write down 30, 60, 100, 200, 300. And then you come back just one by one, you reduce it, okay? You reduce the speed and you get this all back. And the average one is used on all the simulations all the, when you need to match the hierarchies, you are using this one, and you get also some simulation results for friction pressure to compare rheology hierarchy. Okay, you can get the 10-minute and the 10-second gel strengths. Also, you measure it through viscometer. If you have seen any mud report from any drilling company, you should be aware of these parameters, because this is the main parameters for mud that they are using, and all mud companies has these tools, but there is a small difference. They start from 600 RPM, but for cement slurry, we don't have 600 RPM, okay? This is very fast, and this is not applicable for slurry because we are not pumping slurry in that high rates, and that's not representable. That's why we use only 300 as a maximum, okay? Okay, in any cementing report, cementing lab report from any company, first thing you should see, you will see this one, okay, this chart. It can be in different color, but it will be the same parameters. Then slurry thickening time. Slurry thickening time is the most critical parameter for slurry. If you get less thickening time, you will get catastrophe. What will happen? Thickening time test, we do it to determine when this slurry will be unpumpable. What does it mean unpumpable? It will be get gelled, okay? It will be unpumpable. You cannot push down this to the wall. It will stick in one area in the wall. It will stick inside drill pipe, or it will be somewhere around casing, but it will be unpumpable. It will stop. You can pump, you can displace a lot of mud, but it will not go down, or it will not go anywhere. This slurry will stuck there. And you have probably heard about the stuck pipe issues. So this is happening when you have a less thickening time than required. How we calculate thickening time? We have pumping time. Okay, we know that we will pump our cement slurry in this minute. It will take for 45 minutes, and then I will have a displacement. It will be 2 hours. Then I need minimum 2 hours 45 minutes. This slurry to be in the liquid phase to be pumpable. Okay, but is this enough? No, it is not safe. That's why we are adding safety factor. Again, each company, each operating company, each service company has their own criteria. Like BP has one criteria, Total has another criteria, but usually service companies has more tight criteria because this is safety. This is very important for service quality. That's why everyone is more strict in thickening time. How we manage to get different thickening times, because I am adding these additives, cement, and I mix them. So I will get the same time in thickening time, but we have additives like retarder and accelerator. These names already state that retarder, it will increase the thickening time, okay? It will retard it. Accelerator, it will accelerate the process of slurry getting jet up and being unpumpable. So for the surface casing, by logic, we will need less time. That's why we don't need to get the usual thickening time from G's type of cement, from Portland cement, which will be, let's say, 7 hours. It depends on temperature and pressure. So let's say 7 hours, and I need only the safety factor, I need only 5 hours. In this case, what I will do, I will add accelerator to get that 5 hours less time for thickening time, because I don't want to lose my rig time. And for, let's say, for production liner, I need 11 hours for the job, and my cement is giving only me 6 hours, and this 5 hours, how I will get it? I will add a retarder, and I will retard this process. I will extend this process of cement slurry getting unpumpable. Is it clear? We are determining this in the pressurized consistometer, and also there is atmospheric consistometer. Atmospheric consistometer is not used for thickening time, because it is used to get it to get this slurry condition. But for thickening time, we are using pressurized consistometer, because we need to simulate the same temperature and the pressure we will have on the rig. How we will simulate? Again, each company having their software to simulate. I guess one of the previous stations, I got a question that, okay, we don't have any simulator, I guess, don't have simulator, any software, and we are pumping cement slurry with hand calculations, etc. Okay, long times ago, people were doing this, and temperature, pressure was estimated somehow from any formulas, like estimated formulas, where they have got these formulas from experience, etc. But today we have very sophisticated softwares. They are estimating very accurately bottom hole static temperature, bottom hole pressure, and we are using these parameters in thickening time test. And now we can be sure that, okay, we will not get this cement set before we complete our job, and we will not get any catastrophe as a stuck pipe. Okay, pipe is getting stuck and you lose your well. You need to go there, you need to fish, and if you can mill and you can continue. If you cannot mill, then you need to sidetrack. And can you imagine how expensive is this, for especially for deep waters and offshore jobs? So that's why thickening time is very critical parameter. Let's say you can get worse rheology, you can get worse compressive strength. What will happen? Your job will not have a good service quality. You will not get what you have, but you can solve them more easier than this thickening time problems, because you will, if you didn't get good isolation, you will squeeze some slurry, let's say, okay? You will log, and then you will not find good compressive strength. You will wait a little bit more, or you will run another protective liner, okay? You will run tieback. There will be other options, but for thickening time, it is catastrophic. So I told you how we measure thickening time. We are using these consistometers. You can manually edit, okay, I want this slurry to be conditions from, let's say, 25 Celsius. So when you mix it in the surface on the rig, it will have a 24, 25, 28 maximum Celsius. Your starting point is 28 Celsius, and you say, okay, my bottom hole pressure will be 45 Celsius or 85 Celsius, and your simulator shows that, okay, after 45 minutes, you will get the highest temperature and you will get the highest pressure, and you are adding this as your peaks to this machine. You input this data, and it gives you when you get this slurry unpumpable. There is a special units, like we call it PCs, 70, 50, and again, each company has their own criteria that after 70 BC, it will be unpumpable. I don't want to go beyond that, but in reality, you can go up to 100 BC. But companies should take an action to stop this kind of problems, short thickening time, etc. Okay, getting problems. I told you that the short thickening time is catastrophe, but long thickening time is also not favorite, because when you have a long thickening time and this slurry will be there pumpable for longer than you require, and this will change other parameters of this cement slurry. This will affect to its quality. That's why we need always optimize thickening time. Okay, usually you will hear TT. We call it TT test, TT result, okay, thickening time, TT. You can hear this in somewhere, just be familiar that it is thickening time. So after thickening time, we can, yep, did I get a question?
There's a question in chat box. Is this equipment taken on site, the pressurized consistometer?
No, okay, depends on the client, but usually it is not in the site laboratories. Pressurized consistometers I haven't seen actually, but there can be locations like land rigs. We can have a lot of land rigs, and then we can get a very big laboratories inside. But usually these kind of equipments are based on the main laboratory, cementing laboratory of company. For example, for Schlumberger Baku, we have only it in our base, in Schlumberger base near Shihov. Okay, we have that one consistometer. We have a lot of operations on the rigs, and in none of the rigs we don't have a pressurized consistometer, and pressurized consistometer can only be used by lab engineers and sometimes cementing engineers. I know how to use it, but I wouldn't risk, okay? Because this is pressurized, and because it is not my daily job, and if there is no one in the lab, I can do this, but I wouldn't prefer to do this, because these people, lab technicians, lab engineers, they are specialized on this. They are profession. It is their profession, and it's their profession. They know it, of course, better than me. That's why I would let them to do this. And if you take these consistometers or other machines like this to the rig site, you need to have a lab technician or lab engineer to be on the site. And operator companies or like people wouldn't pay for this, right? To have because you can do this remotely. You don't need to have equipment there, because all the designs are completed before the job. And if you have this in the main lab, this is enough. Yeah. I guess in Sakhalin, where you have remote bases that in Saudi Arabia also, I have heard that there is a very big lab on the desert because they have a lot of rigs there, and one of the big laboratory was required there because it is very remote from cities. But for example, in Baku, we have offshore rigs, 4 hours by boat or 40 minutes by helicopter. You can take samples, you can send samples from the rig, and you don't need to have any equipment, these very expensive equipments on the rig. I hope I could answer your question. Did I? Okay, welcome. Yes. Then we can continue with fluid loss. I explained thickening time, and then we go with fluid loss. So fluid loss, this test measure slurry dehydration, like during cementing job or just after the cementing job, how this fluid, this cement slurry, will remove it is water out. Let's call it like that, dehydration easily. It will dehydrate. Its water will be removed from it, and that can sometimes that's good parameter that you would like to get high fluid loss, and sometimes you don't want any fluid loss. You want very low fluid loss, and you are controlling this with fluid loss control additives. Okay, and more something to very big pores in the formation. So high fluid loss would be required. Why? Because you will come there and you want it to lose its water as soon as possible. And as soon as it loses its water, it will get set, right? Immediately set. And if you have a low circulation problem, you would like to get as soon as this loss to be cured. And that's why high fluid loss is required in squeeze jobs. But if you have a liner job, very critical job, you are in formation area, you will get less fluid loss. And we are adding fluid loss in a fluid loss control additive. You are getting high fluid loss, 200, 300, 350, 400 milliliters. But when you are using flat fluid loss control additives, you get even less than 50 milliliter, and you measure it in 30 minutes. This is a specific formula. It will be more information by adding it to any calculator, spatial calculator for this, and they are getting fluid loss number, how quantity, how much milliliter they got during 30 minutes. Okay. Yes, fluid loss, I guess explained. Sometimes it is favorable, sometimes it is not at all. Okay, there are specific cases, there are specific jobs you need to get high fluid loss. Sometimes you need to get very low fluid loss. And when you need to control fluid loss, when you need to reduce it, you are using fluid loss control additives. Free fluid. Always you want to get it zero. It doesn't have any help for you. Okay, if you have more fluid, free fluid, don't confuse free fluid and fluid loss. Like whenever people start to learn cementing, they always confuse these two parameters. Fluid loss, it's measured under pressure. You can see this filter press cell and the assembly, which is API and the ISO standards. ISO standards suggest to use this tool. So this is pressurized. Nitrogen is used in this tool, and under pressure, you press, there are special filters, and you press the slurry, and you wait for 30 minutes. Usually, if you have used any fluid loss control additive, it will take 30 minutes to get some drops, and then you measure these drops, and you add it to your calculator. This is telling you, okay, what is your fluid loss? And when you don't use any additive to control it, actually takes 5-10 minutes that you're having a cap, and this is the pressurized cell. You apply pressure by nitrogen around 1000 psi, and then like it is flowing. All the water are flowing down, and you get a lot of water, like let's say dehydration. When it's getting dehydrated, you get a lot of water, and then you add this to the calculator. It calculates and gives you the result. So this is the way you need to measure fluid loss. And for free fluid in a stable condition, what is on the top of slurry. We are using these cylinders. Okay, they have readings. They have lines on them, and it was showing levels. So you add your slurry on this. There are two types of measurement for free fluid. One is vertical measurement. The second is inclined measurement for 45 degrees. If you have inclined wells, you measure it as a kind of inclined wells. I wouldn't say that this is 100% representative to our well, because our well have dog legs, and it has 40. Sometimes it has 45 degrees. Sometimes it has 20 degrees inclination. So it is not very representative. But anyway, it is better than vertical, right? So in the lab, two versions. One vertical. The second one is 45% incline with inclination. Okay, what I have written, when a slurry is allowed to stand for a period, yes, in a stable condition before setting, water may separate from slurry, migrate upward, and it accumulates in the pockets or at the top of the column. Yeah, on the top of slurry, it is collected, and after you wait for 2-3 hours, you will find that okay, there is a level of water above top of slurry, which is not favorable. You wouldn't get it. And for this one, you need to design your slurry in a way that to get this free fluid zero. Sometimes it depends on the batch of the cement you are using. Like when it comes from manufacturer, it should be in a quality that it is providing zero or near zero fluid loss. Some companies has a criteria maximum less than 2 milliliter free fluid, but most of companies I have worked, they had the criteria of 0 milliliter. Okay, so you won't always get lowest free fluid possible. Any question from fluid loss or free fluid? Nope. Then I continue. Okay, compressive strength. This is the way we evaluate quality of cementing job. Okay, how we evaluate the jobs? We are running logs, right? What log measures how is the isolation there? Okay, how is the zonal isolation? But what gives that zonal isolation? Of course, this is the strength of cement placed there. And strength of cement, how solid, how strong is this? How it can withstand to the formation fluids, how it can, how resistive it is to any change in the well, okay? How it is providing isolation for us. And for this one, always we want to get quicker compressive strength development. We have a few ways to measure compressive strength, and very old version still used, but it is used as an alternative. Okay, this is probably you have seen a lot of videos on YouTube or in Instagram, whatever, like kind of satisfaction videos. They are using hydraulic press. They place a ball, or they place any, I don't know, sometimes some Legos, and then they have a hydraulic press, and this is destroyed. So this is the same tool we are using in the lab. This is hydraulic press in blue color. So it is connected to any one machine, one acquisition system, which is getting data from this hydraulic press, how resistive the material you have put under this, okay, how resistive it is. You are getting it in PSI, converted to the PSI. So how we start the test, we mix the slurry. I have showed you how mix. We are mixing in the mixing bowl, and then we are using the 2-inch cube molds. This is kind of just the molds. Okay, you add slurry inside these cubics, and then slurry gets shape of cubics, and at specific temperature and the pressure inside consistometer we keep it, and it is getting hardness. It's going to be solid and very strong. When it is conditioning and this setting process done, we get this set cement, these cubes. We remove it from molds. Usually these molds easily removed because you are adding some oils, and when you inside this mold you are adding some oil, some greases, so you can easily remove it. You remove it and you put it under hydraulic press, okay. And when you are increasing the uniaxial loads, it's getting destroyed, and sometimes you cannot find any pieces because it is destroyed away, and you need also always have a safety falls around this hydraulic press, this machine. So it is converting this resistivity from this set cement to the acquisition system, and in the acquisition system you are getting a chart, and this chart shows that how strong your sample is. Sometimes you cannot crash it. It gets, let's say 5,000. These tools, hydraulic presses, has, I guess, 5,000. What we have has in a limit of 5,000 psi. And sometimes your sample, cement sample, is getting to be very hard and more than 5,000 psi. If you keep pure cement slurry for, let's say, for 3 days, it will get more than 500 psi for sure. If you don't add a lot of additives to this, if it's a pure cement slurry and you get it more than 5,000 psi in 36 hours, sometimes in 24 hours, and then this hydraulic press will not be able to crash it. Then after you get this load, it is calculated dividing load with the failure at which failure occurred by the cross-sectional area of this specimen, means sample, okay? You are getting calculated. We are getting result from machine, but there is a manual calculation too. Okay, this is the compressive strength that we need very hard cement usually, like always we need to get a hard cement, and this is the way we measure how hard this cement is. Also, there is another way to measure it. It is sonic strength. How we measure it? We are using ultrasonic cement analyzer, UCA test, and this is very famous. You need always to have this result. If this job is critical, it is the first thing you need to do. You need to be sure that the appropriate zonal isolation will be provided by the recipe you have designed. That's why you need to do UCA test. And without UCA test is ready, we cannot start to the job. Actually, this is the rule in the company I'm working. Okay, taking time and the UCA always required. Very important parameters. Actually, the parameters which taking time shows that how safe job will be, and UCA result shows the expected quality of the job, okay, service quality. So both parameters are very important. And in this one, ultrasonically, we measure the strength of cement sample, designed cement sample. And this measures the travel time of the ultrasonic energy passing through the cement sample. So the same way in this UCA machine, we have a special how to call it, kind of molds, but it's a cylindrical molds. You are adding cement slurry inside, and this is mixing. Actually, this is something rotating inside. Very complicated tool, and it is not very safe to use because it is pressurized. There is a very high pressure. Sometimes we are testing 15K psi, and always these machines are placed in a different room. Not in the common room in the lab. Okay, you need to use special PPEs for this. You need to use your glasses, your hard hats always to be on the place when you are working with these tools, and you need always to have a gloves to protect your hands. Again, very dangerous tool. Only specialized people need to use this. And I have also put one table here. This is how we provide this result to the client, or how we provide this result to any evaluation that if this cement is fitted for the purpose of the job. You can see it gives us 50 psi compressive strength, and 50 psi compressive strength it gets in 15 hours, and 500 psi in, again, 15 hours 30 minutes, and we get 5000 psi in 33 hours. And how we define that if this strength is enough for us or not? For example, there is such a criteria, such an estimation that after 50 psi you can start to pressure test cement. Okay, you will not get a problem. After 500 psi you can start to drill the shoe. But for evaluation logs, you need usually to wait for at least 2000 psi. For example, for kickoff plugs, it is very like the most strong cement is required in kickoff plugs, because you are using it as a base, kind of whipstock. Probably you have seen whipstock. So when you want to do a sidetrack, you are drilling, and you need to have a plug here which should guide you to another hole, not the same hole you are drilling, right? That's why it should be very hard. It should be very strong, more strong than your, should be stronger than your formation, because it should guide you to the formation, not down through the plug. And that's why for kickoff plug, it's never recommended to drill before 2000, 3000 psi compressive strength development. Yeah, we run UCA always. This one, compressive strength, sometimes we run, sometimes alternatively we run for UCA. Okay, it's not always required, but this is always required. I guess I finished this session. I don't know if it was interesting for you or not, but what we can do after this COVID, we can. I will try to arrange. I will ask our company, and I will try to arrange a visit to our laboratory in Schlumberger. We have done sometimes this for students. We have agreed with universities and chapters. I guess we can do this, and hopefully this COVID will be over as soon as possible, and we can continue our workshops. I guess I got a question here. Is this also the procedures for the well abandonment? Yes, for well abandonment, high compressive strength is required. Why it is required? Because we need to be sure that we will be safe after this well is deployed. And especially for land rigs, government has required special compressive strength developments, and the number of the plugs should match their requirement, government's requirement. Authorities providing some criteria for you, and as an operating company, you need to obey. Another question, guys?
Okay, let's wait for Kamal. He was writing something.
Mm-hmm.
Okay. So thank you, Munavvar Hanım. I think there is no question. Seems like there is no more questions. So thank you very much for this session. Thank you very much being with us this month. It was very informative and very interesting weekends for us. And I want to clarify some details. So first, either Rahima or me will contact you regarding to quiz results. So also we are planning, if it's okay for you, we are planning to share the presentations next week with participants. And also the site visits that you mentioned, the field trip, if you will also agree, we will be more than happy to help organizing this event for our community as well. So yeah, and I also hope to collaborate with you in the next academic year with our whole new team. So again, we will definitely contact you with that for that. Okay, yeah. Thank you very much for this month. Thank you very much for the sessions. And for the participants, I want to say that next week we will have last session in Petroleum Engineering Course. So I hope to see you all there.
Wagif, thank you very much for your great words. I'm always ready for help, for support, and for these sessions, I'll do my best. And like you understand that currently for COVID situation, we have even I cannot visit to the base without any permission, and we have a very strict rules. But hopefully, after we all get vaccinated, we will go there, and I'll do my best, and easily we can do this with your chapter, you or another team in your chapter. We can do this, no problem. I'll do my best to arrange as soon as possible after we're out of this COVID situation. And I will thank you for all the participants. Like I am really getting happy when I help someone, when I see that someone learned like a piece of information I delivered to you. I'm thankful for this, that you have got it, you have accepted it and received it. I'm happy for this, guys. Thank you for joining, and also thank SPE team. Thank you for the invitation. You know, as soon as my schedule allows, I'm always more than happy to participate, to support, to be with you. Just one more thing, that this quiz result, maybe if guys have 10 minutes, we can go through this. Would you go through that, guys? Or maybe only last question. I found it interesting, and I saw that everyone answered this wrong, and actually I have done the same. That's why I would share it, last question, and then we finish, okay? So this question, let me explain, because I saw this today, and do you see my screen? Wagif?
Yes, we can.
Okay, so this question, everyone answered this wrong, I guess. Maybe in the last participant answered this right, but how it is, you see these lines are closed, you have so you cannot get this field because you have these parts are closed, and you cannot get this one field because this line is closed. So if you get here for the 6, it is already also closed. So for 5, this part is closed, and for 4, again this part is closed, and for 3, your input is from entrance, it is closed, and you have only for 2, which is coming through here, and you have a guide here. So you are getting 2 as field. That was the correct answer. For others, most of you guys answered the questions correct. So if well is overbalanced, it means that you are above your pore pressure, right? Because you are balancing your pore pressure from formation, and you should be below the frag pressure, not to frag formation, and then not to lose your mud or any drilling fluid. This question is very interesting. That guys, some of you has answered this wrong, and I told you last time the trick. What was the trick here? If I am mentioning size it doesn't mean that it is primary job. So primary jobs are the casings, liners. Okay, so these are the primary jobs, not kick of plug, because 8.5 inch means open hole size. So, and surface casing cementing, and which of these remedial cementing job? Of course, squeeze job, and not casing, not conductor, not again production casing. So here is zonal isolation. And this one, I have explained this last time. I don't want to lose time, guys. It is very easy and you have it in the presentation. So this one also, like balance Dampeller two plug method. You had this for calculations. We have covered this. I hope you have written formula down and you can find it also on the internet. So you take squared. This one is squared and divided by 1029.4. Okay, this will be your capacity. You are using inner diameter for capacity calculations. Bit size open hole is provided for equivalent open hole diameter. You are calculating capacity by 24 inch. Then you multiply it by 1.8 because it's 80% annular excess. Then you do back calculation and you are calculating your new diameter. I don't remember what was the answer. I can calculate it, but I guess it was 22.5 or 30. No, it can't be 22.5 because it's 24 inch. I thought it's 20. So it should be 32. I'm not sure if you are answered correctly. Just write down. I don't remember because I wrote these questions 2 days ago. Yeah, for this one calculations, wall thickness, 2 times of wall thickness should be eliminated from outer diameter and it will give you inner diameter. Yes, this one. Yes, guys. So first you drill the hole, right? After you're drilling the hole, you are running your liner or casing to the well. And then you do pre-job circulation. We have mentioned what is the advantages of this pre-job circulation. And then you are pumping your spacer ahead here. Then you drop your bottom plug. Then you are pumping your slurry. Then you are dropping your top plug. Then you pump slurry behind. And then you displace your slurry. So choose the correct statements. I mentioned about them last time. For dry additives, it is preferred to be added on the block plant because you are mixing it with your cement, okay? And this will be done on the bulk plant. But sometimes there are some additives, dry additives, they are in the small sacks and you can add this on the rig side. But you wouldn't take tons of dry chemicals to the rig. How you will deliver it? It will be very difficult. But liquid chemicals, you have not big volumes, so you can do this in the drums, in the cans, or in the IBCs, tow tanks. You can deliver it. You can, for logistics, it will be easier. For dry chemicals, you have a 1 ton sacks, so you get 20 big sacks, 20 tons. How you will deliver before? How you will cut and mix on the rig? It's not possible usually. You need to have a very big silos. That's why for dry additives, it will be on bulk plant, and liquid additives is preferred to be mixed on the rig, because I have seen 2 times that the mixed fluid is prepared in the rig side. It was done in US because base was very close to the rig and you are mixing in the base and it's taking only 45 minutes to deliver it to the rig side by car. That's why it was mixed on the base. But if you have a long distance between your base and the rig, more than 25 minutes, 30 minutes, you would never mix liquid additives on the base. So you always get it on the rig and you are mixing just 1 hour before the job. And I explained the last question. So guys, yes, I guess I would thank you one more time. I see comments here, guys. It made me happy. Yes, I learned lots of things. Thank you very much, Nijat, Leopold, Elmin, Anar, Tual, Kamal, everyone. Guys, I'm happy that you have joined, and if you have learned a little bit, it is my pleasure. Thank you. Bye-bye. See you in the different places in next sessions or in any other activity event. Bye-bye.